The go-to rotation test is similar to the find target test in that it influences our particles' motion and also tests them for a particular orientation in space. In this case, it's rotational orientation that it actually looks for. And to do this, it will actually guide your particles from their current rotation and spin values on entering the event into a second set of values provided by a following rotation or script operator. To use this test, send your particles into a new event with this test in. Immediately below the test in the event, place a rotation operator that defines a new orientation for the particles, or, as I've just said, you can use a script operator that does the same thing. Although the test comes before the rotation or script operator, it will actually override their action during the simulation, but it will use the values that it actually finds in them to define the end rotation value that it must meet. By default, the test will be true when the particle reaches the orientation defined by the following operator, but this can actually be disabled with the tick box. So let's have a look at the parameters for this test, and before we do that, I'll just show you that it's actually set up the way I just described it. You can see the particles actually birthed in this event, and we can see we have an age test here at age 5, and they're sent to a new event where we have a go-to rotation test. There it is there. Now, the go-to rotation test is set up so that it will actually get our particles into the orientation that we need by frame 54. That's frame 54 after end the event, and you can see I'm using event duration for that. Then we have a rotation operator, and that's set up to actually use speed space, the speed space of the particle, which we've covered in another DVD, and it's using an offset of 94.5 degrees on Y to define the orientation that needs to be met before the particle will be true. Now, that is then picked up by the actual test which is before it. So it's a bit of an unusual workflow if you look at other operators, but that's the way this one actually works. So this could be a rotation operator, or it could be a script operator. It could be either of the two. So let's have a look at the parameters. The first parameter, which is just a little tick box here, you can see test true when. And when this tick box is active, which it is by default, the particles will be passed on to the next event when they reach their defined orientation. Of course, when this option is not active, the test element of this operator is no longer functional, and it only acts as a reorientation device to act upon your particles. So it's up to you really. If you've got this active, it'll act as a test. If you haven't got it active, then it'll just obviously force your particles over a certain duration to actually meet a certain orientation. So your choice is there with that particular option. The next area we have is transition by, and this group of parameters allow you to define the time scale within which the particles will achieve the new orientation. As you see, we've got a sync by flyout here, and the flyout does the 3 usual options for defining exactly how the duration parameter is applied. The 3 options allow you to define the duration based on when the particles enter the event, based on the particle's age or an absolute time. The default and generally the most useful option with this particular operator is the event duration, as it gives the particle the number of frames defined in the following duration parameter in which to reach its new orientation. If you used, as an example, absolute time, then that would mean that by frame 54 the particles would have to reach the orientation. So if we had an age here of, let's say, 10, let's go for 15. So it takes up until frame 15 for the particles to enter the next event, which you can see here, where they turn orange, pale orange. It takes 15 frames before that happens, as you can see here. When I get to frame 15, there they are, they start changing. And then if I go to the go-to rotation test and use absolute time, and I'll set this to 11, no, let's go for 12. That means that the particles will actually have to change to the orientation desired by frame 12. Now that is actually before the frame that they actually enter the event with the test in. So that's counterintuitive. It's not really going to work the way we want it to. And you can see that basically it defuncts on this, and it actually just makes the particles equal that value straight away as they enter. So if I set this to something slightly higher, let's say 20, it now has 5 frames to try and get those particles to orient. And there you can see you get a very rapid flip in the particles as they come into the event. They try and reach that orientation. And when they do, they test true. They get sent on to the next event where they're turned red. If I change it to particle age, this is a little bit more useful, but